Okay, so just kind of a quick recap of what we've already done. We've looked at this problem and we said this is a degree 3, which means it has a maximum number of 3 zeros. Now, to start trying to find those zeros, we went ahead and we listed out our potential rationals. We listed out all the factors of the constant and then all the factors of the leading coefficient. Our potential rationals were all the p's over the q's. So we listed out these. Now we started with the very first one, a positive 1, and we evaluated the function. This is using the factor and the remainder theorems. It turned out that that gave us a 0 remainder. So it was in fact an x-intercept, or a 0. Now because of that, we had our first x-intercept here at x equals 1. Now to find the remaining 2, we use synthetic division to go ahead and divide 1 into our function. And we're now left with a quadratic. Now we could continue to plug numbers in to see if we can find another x-intercept. But because this is a quadratic, we should be able to factor, hopefully, and finish solving that. If it won't factor, we know we could use the quadratic formula. So let's if you can get it down to a quadratic, then you've got it from there. Either the quadratic formula or factoring to finish it out. So let's see, if I factor this, 20 would be 4 times 5, and a plus 4 and a plus 5 would give us a positive 9. So to continue solving for x-intercepts, I would have to set each factor equal to 0. So x equals negative 4 and x equals negative 5. So there are my other two x-intercepts. We had one at 1, negative 4, and negative 5. Now it also says use the real zeros to factor f. So I'm going to write this in factored form. A 0 at 1 means we had a factor of x minus 1. A 0 of negative 4 means we had a factor of x plus 4. And a 0 at negative 5 means we had a factor at x plus 5. This is the factored form of this degree 3 polynomial. Now, because we were talking about real zeros, we also could have used our calculator to help us. So I'm going to flip over to my calculator. I have the function already put in. When I graph that, a real zero, you can really see where it crosses the x-axis. So here we have 3 places where it crosses the x-axis. That's all we're looking for. And it looks like it happens at 1, at negative 4, and at negative 5. Well, we've already plugged in the 1 to make sure it works. We could repeat the process. We could plug in the negative 4. So if I evaluate the function at negative 4, that means we'd have negative 4 cubed plus 8 times negative 4 squared plus 11 times negative 4 minus 20. So let's see, negative 4 cubed would be 64 negative. And negative 4 squared is 16 times 8 would be a positive 128. And then minus 44, and then minus 20. So when I go ahead and finish this out, that turns out to be 0. That tells us then that negative 4 was in fact an x-intercept, and we could have used it then. We could have repeated the process with the negative 5 just to make sure that it actually was a 0 of the function, or an x-intercept. And when we do that, negative 5 cubed is negative 125. And then 25 times 8 would be 200 minus 55 minus 20. And that is, in fact, 0. So now we could have used the factor and remainder theorems to show that we have all 3 of those as x-intercepts.